So you'll probably get to solve a problem where you mix an acid and a base together, and you got to find out what the pH is after they've been mixed together. So this is a sample titration problem. And the general idea is we're going to add some base to an acid here, and when the acid and base hit each other, they're going to neutralize one another. They're going to take each other out one for one, meaning that one sodium hydroxide is able to neutralize one hydrochloric acid molecule. So we have an initial scenario here. We have like we're going to give ourselves 100 milliliters, which would be 0.1 liters of hydrochloric acid and a 0.1 molar concentration. So this is a 0.1 molar and 0.1 liters of acid, and we're going to add some base to it. We're going to have a 0.2 molar sodium hydroxide solution added, and we're going to add 40 milliliters or 0.04 liters to the solution. And the question is, what will be the pH after they've reacted? And this really is just a stoichiometry problem, and instead of finding like moles through like grams divided by the molar mass by moles, we are finding out how many moles we have by using our molarity equation. Again, our Fermi molarity equation, molarity equals moles over volume. So this is the equation we keep going back to find the moles when we deal with solutions. Here we're dealing with solutions with acids and bases. How many moles of acid do we have? A 0.1 molar solution and 0.1 liters. So again, we're saying this solution here is 0.1 molar, has a volume of 0.1 liters. That means we have 0.01 moles of acid A, which in this case is hydrochloric acid over here. Now, how many moles of base do we have? 0.2 molar solution, 0.04 liters. That's 0.008 moles of B. Well, who wins? Again, acids and bases, they neutralize one another. They're a match made in heaven. This guy is looking to get rid of hydrogen. This OH over here is looking for one. Well, we have more acid than base. So when they react with each other, we're going to find out how much is left. We're going to take the one that's bigger, so we have more moles of acid. So this is how many moles of acid we have here. And we're going to subtract how many moles of base we have. And because there's a little extra here, you'll see that our base is our limiting reagent, and acid is our excess reagent. After they're done reacting, we still have some acid left over. We have 0.002 moles of acid left over. So what do we do next? Now we want to find out, well, what's the concentration? Again, we know how much acid we have left over, but again, in order to find a pH, we need a concentration. To do that, we need to find out what our new volume is. To find the new volume, this number right here, this 0.14 liters, that's going to come from adding the two volumes over here together. So we had 0.1 liters of the acid, 0.04 liters of the base. If we add those two together, we get a volume of 0.14 liters. So my new volume is adding the acid and the base together. So some of this volume is coming here, and the water levels have risen. We have a bigger volume. So 0.002 moles or 0.14 liters equals 0.014 molar acid solution. And once you have a molarity, then you can take negative log of that molarity to get your pH. So first step for a titration problem, find out how many moles of acid or base you have, or moles of acid and base. Step 2, take the big number, subtract the small number, and you'll find out which one you have excess of. After they've reacted, the excess one's what you have left over. Step 3, you have to find the concentration. To do that, you've got to have the new volume, which is adding the volumes from before, taking that new amount of acid you have that's left over, who has survived the battle, divided by that volume to get a concentration. Once you get a concentration, negative log of the concentration gets you the pH. Now again, a quick note, if this would have been a base problem, and if you had excess base left over, you wouldn't find a pH, you would find a POH. And then you had to take 14 minus that to actually solve for the actual pH.